Last lesson before we get a little vacation. This is assignment 14. We're going to move into working with polynomials, and we're going to start this week by classifying, adding, subtracting. Ooh, I also have multiplying in here too. I decided we're going to cram all of the notes in one day, and then on that last day, we'll just do practice in class. So we're going to add, subtract, multiply, and classify polynomials. So the first thing is talking about what is a polynomial. Polynomials are things like this, right? So they are, I'm going to screw this up. There are terms that are separated by addition and subtraction signs. You are not allowed to have radicals. You cannot have negative exponents. You cannot have variables on the denominator, so variables on the bottom. That goes with the negative exponent, but okay, we can't have any of these. If it has any of those, it's not a polynomial, and none of this applies. So we wouldn't be doing it anyway. We're going to talk about the degree. So the degree, there's two different parts to degree. The degree of a term is simply the exponent. So if you look at this, the degree is 3. The degree of this term is 1. The degree of this term is 2. The degree of the 9, we could change this as 9x to the 0 since there's not an x there. So the degree would be 0. So if we simply say the degree, it just means the exponent. Or if we say the degree of a term, it means the exponent of that individual term. If we talk about just the degree or the degree of a polynomial, it's the largest exponent. So if we said, what's just the plain degree of this? Like here I have the question. It's the largest exponent. So it would be a 3. Standard form, we talked about this when we did when we did quadratics, which is a polynomial. Means that it is in order of the exponents, largest to smallest. So it's called descending order of the exponents. We do not care about the coefficients, which is the number in front. So descending order, largest to smallest of exponents. Coefficient means a number in front of the term. So the leading coefficient means after you put it in order, what is the very first number. And when we talk about graphs, that very first number gives us a lot of information about it. When we talked about quadratics, it told you if it opened up or down, and it had to do with how tall or wide it was. And then terms are separated by addition or subtraction sign. So this one has, that's a term, negative 4x is a term, and negative x squared is a term. So every time you see an addition or subtraction sign, that is a separate term. So we're going to practice those few things with this one. We're going to write it in standard form. So descending order of exponents. The 3 is the largest exponent, so that positive 2x cubed comes first. The next exponent is the 2. That's the next highest. So negative x squared is the next term. And then the 4x, remember if there's not an exponent, it's automatically a 1. So the negative 4x. And then the last term, if there are any constants, they're always last. A constant means that there's no variable attached to it. So that would always be last. So the leading coefficient means once you've put it in standard form, what is the very first coefficient? The very first number is 2. The degree we talked about, the degree is the highest exponent, so that's 3. And how many terms does this have? It has 1, 2, 3, and 4 terms. Let's underline those. There's 1, 2, 3, and 4 terms. Every time you see an addition or subtraction sign, that signals that it's a separate term. So you should pause right here and see if you can do this next problem. Can you try it on your own? Can you get it into form? Can you identify those things? Okay, so hopefully you've tried it. This one, we're going to put it into standard form first. So largest exponent would be the 4. You use the sign in front of it. So this negative goes with the 3, x to the 4th. This plus goes with the 6. So negative 3x to the 4th is the first term. And then the positive 2x. And then the 6 that doesn't have a variable is last. So the leading coefficient, after we've put it into standard form, the very first coefficient, the leading one, leading means like in front, right? The number in front is negative 3. The degree of this, the largest exponent, is 4. And this has 1, 2, 3 terms. So there are 3 terms. Now, polynomial. Poly just means many. So polynomial, it just means many terms. It's of this form and it has many terms. So like a polygon, hexagons and octagons, they're all polygons. They're different versions. So just like with a hexagon and an octagon and a pentagon, that prefix tells you how many sides it has. It tells you something specific about it. We're also going to give polynomials different names. And polynomials get 2 names. They have one name that is based on the number of terms, which is why we're counting the terms. So we're going to pick one name from this first table based on the, this one's degree, and then one name based on the number of terms. Now it's not on the chart, but I am going to give you a little asterisk because when we play Kahoot, some of the multiple choice that I did have different names. So I'm going to give you kind of 2 different, you need to know them both. I'm going to tell you both. Okay. So if the highest degree is 0, that means like this 6 would be an x to the 0, right? Then it is called a constant. Ooh, I need to go back and fix that. It is called a constant. It's just a number. It doesn't have a variable. If my exponent, my largest exponent is 1, that's a linear function. That means it's a straight line. If my largest exponent is a 2, it's a quadratic. Three, we call a cubic. So remember, this is the degree, the highest exponent. So if the highest one is like an x to the 3rd, that's a cubic. And these tell us what shape. This dictates what shape our graph is. Okay, so 4 or more. Sometimes we just say, or some texts, some curriculum, just say an nth degree. So for example, this one, they would just say a 4th degree. If the highest exponent or the degree was like a 6, they would say a 6th degree. But 4 and 5 actually have fairly common names that you should be familiar with. So 4 is a quartic, kind of like quarter. And 5 is a quintic. So quin, the prefix quin means 5. Like if you have 5 babies at the same time, they're quintuplets. Quin is 5, so quintic. Okay, now we need to also give them a name based on the number of terms, okay? And so 1 is called a monomial. Mono means 1, and they're all forms of polynomials. So they're all going to end in meal, right? Poly means many. Monomial means 1. Binomial, like a bicycle. Bi means 2. So guesses on 3. The little thing that you ride with 3 wheels, is it tricycle. So this is a trinomial. And then again, we're going to have kind of two different names that you need to be familiar with. I don't care. Like I really don't care. Like over here, I don't care if you say a fourth degree or a quartic. But if you see it in a multiple choice or on an assignment and it says quintic, I do expect like you need to know what that means. So 4 or more. Sometimes we just say with blank terms. So with 4 terms or with 6 terms, sometimes they just call it a polynomial. Poly just means many. It's less specific because then you don't know how many terms. If you say with 5 terms, then that gives you more information, but either are acceptable. So we're going to practice using that. We're going to write these in standard form, and then we're going to name them. They need 2 names. Naming also classify. Okay, so standard form, biggest exponent first, x squared cubed, plus 7x squared. Then the x to the first minus 11x, and then the constant at the end by itself. Okay. So let's kind of jot down over on the side. The degree of this. The degree is the largest exponent. That is a 3. Number of terms. How many terms does this have? It has 1, 2, 3, 4 terms. So now we go up to the chart. Degree 3 is called a cubic. And the number of terms is 4, so you can either say cubic polynomial, or you can say a cubic polynomial with 4 terms, or just a cubic with 4 terms. I'm going to stick to the 4 terms just because it's more specific. So pause here and see how you do on it. We're going to write it in standard form. So the x squared is the highest exponent. And remember that this sign goes, use the sign in front of it. So it's a negative x squared. And then plus 3x plus 5. So the degree is 2. If you scroll back up, look at your chart. If it has a degree of 2, that's called a quadratic. And there is 1, 2, 3 terms. So now I'll go back up to this one where it lists the names based on the terms. 3 terms is called a trinomial. So that's all the classifying. If you want, you could actually stop there because that's all we're doing the first day for our activity. The next lesson will have the rest of it, but I'm going to power through. I'd rather just get them all done at one time. So we're going to add, we're going to subtract, and we're going to multiply. Adding and subtracting. You may only add and subtract like terms, which means that they have the same variable with the same degree. Same variable, same exponent. Okay, so like here, the 6x cubed plus 2x cubed. They're both x to the third, so I can add them together. I add their coefficients. 6 of them here plus another 2 of them here makes 8x to the third. I'm going to put them in order as I go because I'd rather save myself a step. The next one after x to the third would be x to the second. So there's 1 right here and x to the second. And then minus 8x to the second. Those are like terms because they have the same variable with the same exponent. So we have a positive 1 and a minus 8. 1 minus 8 is negative 7x squared. The next one would be x to the first. So here's 4x to the first, and then there are no more over here. So there's nothing to add to it, which means I just have 4x to the first, but you don't need the 1. And our last one are the constants. So -7 plus 3 is -4. The next one I'm going to show you is subtraction. Subtraction is basically the same thing. I mean, you're still subtracting like terms. Here's the issue with subtraction. People will subtract this first one, and then they'll get down to the x squared, and they will do 6x squared minus 2x squared, and they'll get it wrong. So what I do is I distribute this negative through in the beginning so that I don't accidentally miss any of them. So I would distribute this like it's like a -1 in front. I would make this a negative. I would make this one a negative, and I would make this one a positive because a negative and a negative makes that a positive. Then I'm just adding because I already put the negative into the whole thing, and I don't have to remember to do it each time as I go, because promise you will forget at some point. If you do that, then it becomes the exact same problem as up here. So I'm going to look for like terms. We have an x squared y squared and then another x squared y squared. This is now adding because I already did the negative. I already did that. So x squared y squared, x squared y squared. They have the exact same variables with the exact same exponents. Those are like terms. So I have 3 of them minus 2 of them is 1 x squared y squared. Then I have then just x to the first y squared, and then there's another term that has x to the first y squared. So here's 2 of them, positive 2, minus 3 of them is minus 1 x to the first y squared. And then the x squareds are last. So here's positive 6x squared plus 2x squared is 8x squared. So people don't miss this because they usually miss it because they forget to distribute that negative and they don't subtract once they get to here. Okay, and then our last, you ready to finish up? Our last thing is multiplying. So when we multiply, we're going to distribute. There's also something called the box method or the area method. If you have done that before, please feel free. I for sure would do it if we were in class. I really do like it. I just didn't want to take the time to do it right now. Although I do, like I said, I do really like it. So if you know it and are comfortable with that, by all means, go for it. Okay, we're going to stick to distribution. So I am multiplying the r plus 2 by the 3r minus 1. I need to take this r and distribute it through and multiply, because this is a multiplication problem, by both terms in the other group. So I'm going to multiply r by 3r. Okay, so when you multiply the coefficients, which are the numbers in front. So I have a 1 times a 3 is 3. And then when you multiply the variables, you add exponents. So I have an r to the first and an r to the first. So I'm going to add those exponents and get r to the second. Then I'm going to distribute that r through to the -1. R times -1 is negative r. We already did this last week, the other day. Remember when I was... when we multiplied vertex form out and got it in standard form. So then I'm going to take the 2, the other term, and distribute it through to both of them. So 2 times 3r is positive 6r. And then 2 times -1 is -2. So you get everything multiplied out, and then you take a look at it to see, are there any like terms that we can combine? Well, I have 2 terms that have an r in them, an r to the first, so I can combine those and get 3r squared. -1 plus 6 is 5r, and then minus 2. If it's a longer polynomial, you follow the same process. So I'm going to start with the first term, the 2m, and distribute it through. For the first term, 2 times 3 is 6. And then we get m to the, remember you add exponents. So there's a 1 here, and then 2 more, m to the third. 2m times negative 4. 2 times negative 4 is negative 8. M to the second, because you add exponents, 1 and another 1. And then 2m times 2 is 4m. And then I'm going to do the same with the 5. I'm going to distribute the 5 through. So 5 times 3m squared is 15m squared. 5 times negative 4 is negative 20m. And 5 times 2 is 10. And then we do the same thing we did before, and we look for like terms that I can combine. So here I have an m squared, and then I have another term with an m squared. So I'm going to be able to combine those two into a single term. The m cubed, there's nothing to add it to. So 6m cubed. And then for the m squareds, I have negative 8 plus 15 is positive 7m squared. And then the m to the first, I can combine those. Positive 4 minus 20 is negative 16m. And then the 10 is the only constant. So if you're multiplying 3 things, just pick 2 of them to do first. Ignore one of them and multiply 2 first together. So I'm just going to take the first 2. Okay? I'm going to multiply these 2 out, and I'm going to ignore the m plus 4 for now. So m times m is m to the second. M times negative 2 is negative 2m. And then distribute the 1 through, 1m. And negative 1 times 2 is negative 2. We still have the m plus 4. Like, don't completely forget it. It's still there. We're just not doing anything with it quite yet. So just like we did above, we're going to combine these 2 middle terms. M squared minus m minus 2. And then m plus 4. So now we have these 2. I'm going to do the exact same thing. I have 2 things that I'm multiplying, and I'm going to distribute. Don't go distributing and trying to do it all at one time up here. Do not do that. So I'm going to take the m squared and distribute it through to the other group. Remember, you're doing it to the other group. M to the second times m is m to the third. M to the second times 4 is 4m squared. Then I'm going to do the next one. Negative m times m is negative m squared. And negative m times the 4 is negative 4m. Then I got one more because I still have this 2. I have to multiply it also. So I'm going to distribute it. Negative 2 times m is negative 2m. And negative 2 times 4 is negative 8. So as many terms as you have here, you distribute each one of them. You could have like 4 here and 5 here. You just take each one of these and distribute it through to every other term. And then just like before, our last one. So I'm going to combine these 2 terms and these 2 like terms just to get it simplified.